Hi everyone, so this is an introduction to stacks video where we'll be going over some basic concepts and real life examples. So first let's start with the definition of a stack. So a stack is basically a collection of elements where the last item added is the first one to be removed. This is known as the last in, first out, or LIFO principle. Think of a stack like a pile of Oreos. You add a new Oreo to the top of the stack, and when you take one out, you start from the top as well. The newest item is always added to the top, and you remove items from the top as well. So stacks are everywhere in our daily lives. Let's look at some real life examples. The first one is a back button on a browser. When you navigate through web pages, each page is added to a stack. When you click the back button, it returns you to the most recent page you visited, following the LIFO principle. Next is a deck of cards. When you shuffle and stack cards, the last card added to the stack will be the first one that you draw. Next, consider a pile of plates. In a restaurant, plates are stacked one on top of another. To get a plate, you take the one from the top, and when adding a plate, you also place it on the top. Finally, consider a pile of books. If you stack books on a shelf, the most recent book is added to the top. When you remove a book, you also take the top one first. These examples all show us how the last item added to the stack is the first one to be removed, following the LIFO principle. Now let's look at some of the core functions. So the first core function is pushing, and the push function basically adds an element to the top of the stack. So in this case, you can see that this box will be added to the top of the stack here, right at the top. The next element is popping from a stack. Popping from a stack is when you remove the top element from the stack. So in this diagram, you see that when we pop, we are removing the most top element from the stack. Finally, there's peek. This function allows you to view the most top element of the stack without removing anything. So in the peek function, we do not add or remove anything. We simply just are able to see what is at the top. These operations together help us manage the stack efficiently, and they ensure that you can always access or modify the top element of a stack. So now let's try an example. We have a stack right here, and we want to push 4 into it. So that'll look something like this. Where the 4 gets added right to the top, which follows the last in, first out principle. Now let's try popping. Remember, we also pop from the top of the stack, so in this case, we pop the 4 off. Let's try popping again. So in this case, the 3 is the most top element in the stack, so the 3 will be removed. Finally, let's try pushing again. Let's try pushing a 5, and once again, when we're pushing, we add to the most top element of the stack, so the 5 is added right on top. So finally, let's go over some secondary functions. So the first one is isEmpty. The isEmpty function returns true if the stack is empty and returns false in all other cases. And then there's also the size function, which returns the number of elements in the stack. So in this case, this stack would return true because the stack is empty, and this one would return false because it has 2 elements in it. And in this stack of books, because there are 6 different books, it would return 6 as that is the size of the stack. So these secondary functions help us manage and understand the state of our stack, and they make it easier to work with in various applications. So to summarize, today we covered the LIFO principle, which the stack follows, which is the last in, first out principle, meaning that the last item added is the first one to be removed. We went over some real-life examples that appear in our everyday lives, like the back button on a browser, a deck of cards, a stack of plates, and a pile of books. We went over some core functions, like pushing, which is adding to the top of the stack, popping, which is removing from the top of the stack, and peek, which is viewing the top element of the stack without removing it. And we also went over the secondary functions isEmpty, which checks if the stack has any elements, and size, which returns the number of elements in the stack. By understanding these concepts, we can effectively use and implement stacks in various programming scenarios.